I'm Donald Trump, and I approve this message.
Who are the
APC students? Kevin Durrick.
I'm done with science for today.
Dwight Dutton.
Way to go there, buddy.
between them more than 30 years of
APC Physics Labs.
joining them?
Jackie Wong.
That's why we can never have anything nice.
Cody Morris.
I'll try not to let you guys down.
And
Deanna DeLuca.
You know, I went to college for this.
they don't just tell the
Labs.
they put them to the test.
Welcome to the Wong News, where we are not going to be covering a news topic today. Instead, my colleagues,
Cody. Kevin.
Deanna.
and I, Jackie Wong, will be discussing an experiment titled Centripetal Acceleration. In this experiment, we'll be using LogPro for gathering force, velocity, and radius data for a swinging pendulum, analyzing the data collected, and finally, determining an expression for centripetal acceleration. Now, I forgot to add this in, but centripetal acceleration is defined as the rate of change of tangential velocity in a circle. Now back to you, Cody.
Good morning for Wong News. This is Cody Miller, here to tell you how to do this experiment yourself. First of all, you're going to need LogPro, as well as a photo gate, which you'll use to measure the speed of your apparatus. Also, you'll need mass hangers, and of course, masses, as well as the strings, hang everything on. In addition, you need a meter stick to measure them.
In order to do the experiment, there are a few things to do. First, you have to tie a hanging mass at the end of a length of string. The other length of string will have another knot where you attach the string to the dual range force sensor. When deciding how long the string will be, ensure that the string has a length between 0.7 and 1 meter. Place a photo gate beneath the hanging mass so that the mass can swing between the photo gate. Be sure to let the photo gate detect the mass using its sensor. After setting up LogPro as directed in the lab, be sure to zero the force sensor. The first set of data will pit force versus velocity. After noting the length of the string and the mass of the hanging mass, lift the pendulum back 15 to 20 degrees. Drop the mass when you hit collect in LogPro. After storing this trial, execute more trials until you have 7 trials, each with an increasing angle. After that, you will have to pit force versus length. The length of the string will be changing now. Be sure that the initial length is at least 0.9 meters. Pull the pendulum back about 15 to 20 degrees. And drop the mass when you hit collect in LogPro. After storing the trial, execute more trials, each with a decreasing length of string. Be sure to realign the photo gate after every trial.
This is Deanna DeLuca reporting for the Wong News. Thank you, Jackie and Cody, for that introduction. By this point, you should have collected all of your data. However, by this point in the year, you should know that your data means nothing unless you analyze it. Whether you're using LogPro or LabQuest to collect your data, I recommend that you evaluate your data using LogPro. Okay, so now that you're in LogPro, you're going to want to disconnect your interface from your computer prior to opening a new file. Okay, for part 1, start a new file and manually input the data you just collected, force versus velocity. Look at the graph. What is the relationship between the highest value for the tension force of the string and the maximum velocity of the hanging mass? If you do not have a linear graph, you're going to need to linearize the graph so that there's a direct relationship between the force and the velocity. Show both curves on the same graph. Then save your file and write the equation for the line for the linearized graph with simplified units. For part 2, force versus radius, Start a new file and repeat the same steps using the different variables.
Dr. Kevin, in correspondence with the Wong News, here live from Coastal Carolina University to bring you the latest information about physics. Thank you, Deanna, for the handoff. And to begin, remember the data collected is never perfect. There will always be some errors that we cannot control, and it just happens, guys. So anyways, to begin, the variables that were collected were force, which is in newtons, velocity in meters per second, and radius, which is in meters. Also recall that a pendulum's motion is in a semicircle / arc. This will be important in a second. As we all know, a semicircle is half a circle. That's radius r. Now, because the motion is in a semicircle / arc motion, there will be some sort of centripetal force that points inwards at the object. Force would be here, F centripetal. Now, because it's a centripetal force that acts on the bob here, which is pointed up, and this is where the force sensor is. So, right here, force sensor. Disregard my bad drawing skills. It's just really bad. Anyways, so the centripetal force is also equal to the tension force in the string that is connected, which in theory, the centripetal force is equal to mv squared over r. Now, centripetal force is also equal to mass times centripetal acceleration, which is what we're looking for, which is that mv squared over r part.
But wait! There's more!
If you want to calculate the centripetal acceleration at any point along the circle, you have to add a cosine theta. Theta being the angle from here, say. There you go. So, it'd be to get the centripetal force at that point. So F of C, we'll call this point A, for example. At A will equal to mv squared cosine theta over r. There you go. Back to Jackie in the studio.
Now, that is the basic experiment that Deanna, Kevin, and Cody and I laid out. At the end of the experiment, there is a small extension that Kevin will now explain to you guys.
Back to Dr. Durick. There is a difference between the centripetal force and the centrifugal force. They are literal opposites of each other. Centripetal force points inward into a circle or semicircle. Centrifugal points out. So, the example that we like to state is the gravitron. As you know, big spinning ride, blah blah blah. However, the centrifugal force is the friction force. So, if I draw a nifty-difty force diagram right on here, you have a centripetal force that's going here, and you have a force of friction going this way to keep the rider in place on the loop. So technically, that force of friction there is the centrifugal force, which doesn't actually exist. So, the reason why we would use the centripetal force meanings or way of explaining it in this is to just make it more precise. I mean, if you just say there's a centrifugal force going this way, it's really ambiguous and it's lacking information that you would need. It doesn't describe it at all, and that's why we use centripetal forces in physics.
Okay, so we're not using it because what?
Okay, so you have, this is gravitron right here.
Okay.
Okay? So you have the centripetal force going inward. And you have a centrifugal force going the other way to keep the rider in place. Yes, ma'am.
Can't you just say that centrifugal force is commonly mistaken as that force of friction?
No.
Because it doesn't actually exist. Because there's no such thing as a centrifugal force.
That's what I said.
Yes, but you said that we don't use it. But you said like it exists.
It exists, but it doesn't exist.
What?
It doesn't exist in terms of inertial force, as per se. But however, kind of does exist because there's things called centrifuges.
Okay.
Okay? And they bring things into the center and exert a force outwards, also known as centrifuge. Okay.
And with that note, I'll leave you guys with the bloopers. Enjoy them.
Jackie.
Oh, this is a blooper, Osh. We're in school, dang it. Let me fix this. I hate that sentence. Alright, here we go.
Try to look more at the camera.
Dr. Kevin. Okay.
I'm gonna mute the audio, so you're not gonna be able to hear what you're saying right now. Unless I don't mute the audio.
Thanks, Jackie.
You're welcome.
Dr. Kevin, in correspondence with the Long News, here live at Coastal. Oh, I thought this is Coastal Caroline. Centripetal force and centrifugal force.
Google.
See, this is the kind of crap I have to deal with. There's a difference between centripetal force and centrifugal force. Wait, how do you say it?
Fugal. Centrifugal.
Okay, centrifugal.
Centrifugal. F-U. See, just remember F-U. F-U.
So,
That's it. Let's go to the end of life.
does it matter really? We got 100 on the project in ComCub,
I
so.
didn't.
It's because you weren't in the wrong news.
Vote for Riley. Reppin'.
Maybe you shouldn't have stuttered.
Kevin, everyone else didn't get points off for stuttering because mine was live and everyone else's did their nominating.
It's because they cut it.
Exactly! Okay, so now that you're in Logger Pro, you need to disconnect your interface from the computer trying to... Oh, I hate this so much. Okay. I need to...